Thank you all for coming. Today we're going to talk about lights out warehouse. We hear a lot of things being said. We were just talking a moment ago, me and the gentleman here in the front row, about a facility in Shanghai for JD.com that says it's a lights out building and only 4 people run this huge e-commerce fulfillment center. That's not exactly true. There are a lot more than 4 people in that building doing a lot more things than sitting at a keyboard and a bunch of screens saying go, no go. So we're going to talk today about what's realistic, particularly when we're thinking about here in the United States and the technology and how it's being deployed. So my name is Mike Futch. I'm with a company called Tompkins Robotics. We're down the way in booth 9002. And you'll see a couple of pictures of our technology, but also a lot of pictures of other technologies as we go through this presentation today. So our objectives for the conversation is to talk about what are the critical constraints that are facing companies today. And one of the key ones are the workforce. There's a rise in demand, a rise in volume, and there's limitations on what we can accomplish. It's not only just the workforce, but it's also infrastructure as well. Facilities, equipment, the entire ecosystem from manufacture through to delivery to the end customer interface point, whether that be your front door or at a store shelf. We also want to talk about what advances in automation, particularly in robotics, because where we're sitting at, we believe robotics is the future. I don't believe 15 years from now people are going to be buying a traditional tilt tray, for example. They'll be buying different types of things that consist of a fleet of vehicles and autonomous units that accomplish the work. And so we'll talk about how the future is changing and then what advances will impact those critical constraints. How do we use this technology, robotic and in different types of automation, in order to improve the effectiveness and performance of your supply chain? So there are certain constraints that are really ones that drive bottlenecks and limitations in the supply chain for companies today. The first thing I want to talk about here is the evolution to each. So back in the old days, it was all cases going to stores or pre-packs going to stores. There was very little eaches and e-commerce was non-existent. Over the last 20 years, we've seen the proliferation of e-commerce where we're sending 2 or 3 pieces like this to a customer, and the labor content to fill that order is much greater than it is when you're handling cases 12 to 36 items at a time when you make a move. We've also seen where companies, retailers have tried to cut their inventory levels, and so they're not just sending cases to the store. In many cases, they're sending less than case quantities. So once again, we're handling individual pieces. That drives an increase in labor and content and actual touches in the warehouse. So in addition to that, we've got facility constraints, space, right? Nobody wants to build more space, have more asset under roof. And so there's some critical constraints as far as the buildings that we have. If we're having to process more volume as we grow through the same space, that puts a limitation on us. Storage systems are being stressed, primarily from a proliferation of SKUs. SKUs continue to grow and grow and grow. Volumes grow would drive up safety stock and cycle stock. So between the organic growth and the proliferation of SKUs, you're seeing a real constraint on the storage and delivery mechanisms inside distribution and fulfillment centers. The next one that's on the page, we don't even have to talk about. Nobody wants to spend more money than they have to. And then the last thing, labor is scarce. We have record low unemployment. Typically, to expand capacity from a volume perspective, companies are going to more shifts. If you already have a tight labor market and you're adding shifts, where do the workers come from? And this all creates a big problem in the marketplace. So the workforce is a key constraint, one that we should spend a moment on. We all know about the unemployment rate, record lows. It's even worse than that in some places. If you think about distribution hubs where you have multiple 750,000 square feet facilities to 1.25 million square foot facilities, what you have is a limited number of workforce, a limited number of people that can drive the distance to come in from the outside, the immediate geographic region. And so those large buildings are competing for that workforce. It's already a low unemployment rate of maybe 3%. Now you're having to pay more wages and trying to siphon workers off from other people to augment your operations. So it's really hard in certain markets. I'll give you an example. In Bethlehem, Pennsylvania, there are multiple very large fulfillment operations there. I have seen in that market a facility that's running one shift because they can't run three shifts. Because if they ran three shifts and put the workers across all three shifts, they'd have to triple their management and supervision for the operation. So they run one shift wide open at capacity, and the facility is unutilized on the other two shifts because they cannot get the workers to operate the building the way it's configured today. Excuse me. Another impact is the service economy. More and more jobs are going to doing services, whether that be a travel agent or in food service or whatever, and so that puts a further constraint on the workforce that's available to do distribution functions. All of this drives an unsustainable situation. And the last thing that's on this page, I'll point this out to you, right here. Traditionally or historically, you've seen low growth rates, and if we're reducing our cost per unit just a little bit, everyone was happy. Today, the growth is exploding, particularly with the each and the e-commerce and everything that's going on there. But if we don't dramatically reduce the cost per unit, how in the world can you do free shipping and do all this stuff where you're getting product to customers same day, next day, 2 days? You've got to dramatically lower that cost in order to be competitive without having to charge a premium. And so that's a real pressure that companies are facing today. So if you couldn't guess by now from the things I've said, the solution as we see it is automation through robotics. And a couple key points here. Robotics have matured tremendously over where they were as recently as a few years ago. So everyone has seen in the show here all these pick and place robots. 5, 10 years ago, they could not do the things they can do now. 2 years from now, they'll be able to do twice what they can do right this minute. It's very much becoming mature. It's becoming more capable, and it's meeting the three, in the case of the piece pick, it's meeting the 3 R's: improve rate, improve reliability, and improve range of products and items that can be handled. It's not just the pick and place robots. Other robots are doing the same thing, creating a blur of the separation between what a human can do and what a machine can do. And as machines start to be able to do the same things in many cases that a human can do, repetitive, difficult, or taxing to a human types of tasks can be automated. The Moore's Law is definitely in play here. The Moore's Law is every 2 years, capacity or performance doubles while the cost comes down to half. So it all goes back to Moore's Law was actually talking about computer chips. Twice as many chips and resistors, the elements on a chip in 2 years at half the cost, so the computing power was going up. It's also applicable to robotic sortation, robotic pick and place, ASRS solutions, etc. It's on an upward trend like this. It's not flat, it's not at a 45-degree angle, it's going upward. And then if you think about all of this, maturity, blurring the line between people, Moore's Law, the scalability, flexibility of robotics, it's not a matter of whether or not companies are going to use robotics down the road. They're going to have to. It's become a reality. And as I said earlier, I don't think you're going to see the same types of systems. Some of the things you see out here today won't exist in the future. And there'll probably be some things that we don't even see out here now that'll evolve and be out here on the show floor 5 or 10 years from now. So if we think about trying to do a lights out facility, if you're going to do a lights out facility, you got to automate it so you can take the humans out of the operation. There are a lot of different things that happen in a distribution or fulfillment facility, all the way from a truck backing up at the dock till the truck outbound leaves from the dock. So you've got to do the truck load and unload. That's been an extremely difficult thing for people to do in the past. And we're making progress in that area, but it's not all the way there yet. Moving things through the warehouse, that's been around for a long time. Many of you remember the AGVs from back in the 70s and the 80s. But the AGVs have taken on a whole different meaning when you think about a robotic one that's collaborative and can roam in free range around the warehouse. Storage and retrieval, we've all seen the big ASRS systems that had the big crane going up and down, whether it was a unit load or a mini load. Now that's being replaced more and more so with high-density systems like an auto store or an Ocado, or a system that's a shuttle-based system like Dematic or Canop offer. Order fulfillment, tilt trays, bomb bays, cross belts, put walls, slide trays. There's just a wide variety of things that have traditionally been used in the past. And then packaging, we're all familiar with the auto bag, auto box. That's had limitations in the past, but it's getting more and more prevalently used and capable. And then finally, sorting. When I say sorting here, I'm talking primarily about the outbound side, because if it's for order fulfillment, it falls under the order fulfillment bucket. So think about poly bags, boxes, large and small, going to homes and going to stores and going to other businesses. So when we talk about the automation, and particularly the robotic automation that we could use, traditional has been large fixed assets. Think about conveyors. You would have pallet rack that items would be stored in. It would be manually unloaded with human-driven fork trucks. Human-driven fork trucks take pallets off of the truck. They put them in the rack. They move into storage, into rack. They would then have maybe order picker that would go up and down and pick the items onto totes, onto the order picker. The order picker throws those cases or totes onto a conveyor system. Conveyor system goes to a put wall where a human puts them into slots. Another human takes them out and then takes them into a packing station, where many times they would scan each item for verification of the items before they pack it out. Well, we see that as all changing. Instead of having these large systems, which, by the way, take a long time to install, cost a lot of money, are very asset intensive, a lot of heavy steel, and very inflexible, to a rapidly deployed fleet of autonomous or smaller quantity units that can be robotic in nature. And by its very nature of being robotic, you can add elements to the system, you can reconfigure the system, it can grow with you as you grow, you can pick it up and move it from one building and put it into another building. So there's a lot of advantage, particularly in flexibility, cost, and speed associated with robotic systems replacing large fixed asset systems in the past. A thing that's driving that is the intelligence and control. So most of these pick-and-place robots that you see, if you talk to those guys, they'll tell you about their artificial intelligence and their machine learning. And so through their cameras and through their grippers and sensors, they repeat the motions of picking and placing things over and over and over again. And as they do that frequently, they are learning through artificial intelligence and machine data how to better handle individual items. They take note of what happened when they drop something. They take note of what happens when something doesn't go the way they want it to go. And so they slowly but surely, through artificial intelligence, become better at doing that task. That's one thing that's going to allow, instead of it being a growth like that in the prevalent use of these types of automations, to allow it to go like that. The intelligence of the systems is far outpacing what we had in the past. We're getting to where we can do human tasks. We can't do everything, but the number one places where we want to use automation are in difficult, highly repetitious, ones that are taxing to a human being, in other words, very tiring, where their productivity may be 500 an hour at the start of the shift, but by the time they worked 8 hours, it's degraded down to 350 units per hour. Those are the ideal places to do it. And also where we can get a higher utilization of some of those assets like space and facilities by using a high density type of system with machines. By using Some of the things I want to talk about on the next few pages, we can help address the constraints on space, labor, capital, etc. And the robots are a key point of that and something that's driving the success in that arena. So now I'd like to take a few minutes and talk about the individual areas. And these pages are talking about those major flows in the distribution center or fulfillment center. And what we'll talk about is where we stand, where we came from, where we're going, and how far advanced it is. And some of these will have not so much advancement, and others will have a lot. And by the time we get through with this, you'll understand that you can't really turn all the lights out and walk outside in the parking lot and the building run on its own. It's a nice thought, but we're not there yet. So in dock operations, we typically have pallet and carton handling. It's mostly done with vehicle-driven operators, human-driven vehicles, or people inside of a truck slinging boxes onto a conveyor or onto pallets as they stack them off floor stacked positions, much like in the picture at the top of the page. You can see the boxes stacked. And so where we're going with this is to try to automate that using robots. The most difficult truck, as you can well imagine, think about a UPS truck. You go in the back of that truck, there are big coffins that have a lot of boxes in them. There are bags just thrown all over the place, filling every little cubby hole, and then a wide variety of boxes, box shapes, weights, sizes, all of that. And so to get a robot to be able to pull all that stuff off that truck effectively and put it into the building is a very difficult task to accomplish. And so where companies are going with that is typically to use a machine, and that machine will go in and grasp the boxes and bags and put them onto a conveyor or onto a pallet or some mechanism to get them out of the truck. That's proven very difficult when you're trying to do poly bags and you're doing boxes. Boxes are easier. Uniform boxes are even easier than that. But it's very difficult to do with poly bags. And so I was using UPS as an example a moment ago. Even though there's been some experimentation, there's not a lot of progress that's been made on being able to unload their trucks automatically. On the pallet side of the equation, there are self-driving forklifts that are around here at the show, and those are pretty good. And so we've made much more progress on being able to unload a truck automatically with a forklift that doesn't have a human operator than we have with the machines to unload the truck, all loose stacked and willy-nilly. The technology is really in its infancy as far as where it's at. If I had to compare truck unloading robotics to the pick and place guys you see out here around the show, they're far behind. But that doesn't mean that they can't catch up. So if you start looking at the overall picture, probably about 50% could be automated if there's an economic justification. That's another obstacle on this particular technology. It's still very expensive. And so you don't get a good ROI right this minute. It's more used when there is a labor shortfall that you can't overcome and not based on the economics. As far as moving things around the warehouse, as I mentioned before, we've had AGVs and conveyors and other things around for a long time. But the new robotic versions that you have, whether that's an Auto or a Futch or any one of the others that are here, there's quite a few of them. These robots today, they don't have a wire in the floor. They don't have a grid pattern that they have to follow. They can go all over the entire warehouse once the warehouse is mapped into their control system. They, in many cases, are collaborative with human beings. If you stand in front of one, it will stop, and in most cases, go around you. They recognize each other and stop and start. They can interact with lift trucks and other obstacles and moving pieces of equipment. So they've really come a long way. And they can do anything from a several thousand-pound pallet down to a small tote that only weighs 20 pounds. And these types of vehicles have really progressed a lot. And it's been pretty impressive, including to the point where everyone's heard of Kiva, I assume, but if you look at the robot over here, they're even using them to move storage shelf sections of inventory around the warehouse to and from pick locations and back into dense storage. And in that particular application, the robot actually runs underneath the shelving legs and picks up one and brings it out. There's a lot of capability here, and when we look at how much of the movement to and from and around the warehouse, I would peg it at about 85% of all the moves in the warehouse could be done by robots today, and probably about half of those would be a good economic return on moving. Now, if you've got a conveyor that's only 5 years old that's moving everything from the dock to the storage area, I'm not suggesting that you tear that out. But when you think about replacing that or augmenting it down the road because it's at its limitations, robots would be a great source here. Next topic we want to talk about is the storage and retrieval. And on this particular page, we've got a couple of different high density types of systems. In the past, it would be a system that's 40 to 120 feet tall with a fixed mast crane, putting pallets in and out, or it would be a mini load that's 20 feet to 60 feet tall, putting in tiers of product. And so you always had a big fixed crane for an automated storage and retrieval system. Or you had something like a carousel system, vertical or horizontal, where it would spin around and you'd put stuff in and you'd take stuff out. The robotic versions of automated storage and retrieval are a different breed. They are typically using robots either inside the storage structure itself or above. The ones that are above, think of AutoStore or Ocado. Robots run above, they pull things up to the top, they dig things out if they're underneath other totes, and they bring those totes to pick ports for an operator to pick the items, and then they'll put it back into storage. There are also other high-density systems, like Robotics is a company that has robots that look a lot like a shuttle robot. They go down through hollow cylinders in the storage and access northeast, west, and south shelving locations and move product up and down and out to pick ports as well. And then everyone's seen the shuttle systems, whether you're talking about Dematic, Canop, or a host of others that are out here at the show. Those have been around for quite a while, and there's still more of them being installed. And the evolution of that has been with the micro-fulfillment. So you have Fabric, Takeoff, Alert, and other companies like that that are putting small versions of these systems at the back room of a large supercenter or grocery store, or at a dark store or a micro-fulfillment center in the local market that services multiple customers and multiple stores from a single location. And those are just smaller versions. But it's a prime example of what you can do with robotics. Before, in the past, when you were doing a large shuttle system, you couldn't put that in the back room of a store. But because of price improvements, performance improvements, and scalability, you now can put that type of thing at a micro-fulfillment center where the customer interfaces with you at the store. The high-density ones are very good for high numbers of SKUs. If you've got a facility that's already full, and it's got 100,000 SKUs, and you need to add 20,000 SKUs because of your e-commerce business, where are you going to put them? You can't get them into the same space that you have. These types of systems allow a higher density because they're taking up some of the air that's in a traditional system and putting storage there. The technology is very mature. The only items that really can't be done in an automated storage and retrieval system like we're talking about are the things that are extremely large. In many cases, you wouldn't want to put a soup array. And when I say a soup array, I'm not talking about the 20% of the SKUs that make up 80% of the volume. I'm talking about the 5% of the SKUs that make up 50% of the volume. You don't want to put all of that inventory into a machine like this. You want to do dense pallet storage for some of that product. This can be the picking port for it, but not for the high storage for those types of items. And there's some other outliers as well. But we estimate about 80% of all the stuff that's being stored today could go into this type of system. And when we talk about something that's lights out, a key thing to point out is this is one of the few parts of a warehouse that once you install this type of system, that area can be lights out. There's no human that goes inside of this machine unless they're going there to do some maintenance function. So when we start talking about order fulfillment, that's a wide range of things to cover. Traditional has been order pickers, people picking from flow rack, pick and pass. There's a lot of different things, picking from carousels. A lot of those systems are still in place, but there are a variety of different ways that you can use automation and robotics to do those functions today. One is the goods-to-person system. I used the example of Kiva a few minutes ago. That's actually a robot that brings the shelving unit out to a pick port or a pick point, and then a person would pick those items and put them into shelf locations or a put wall. There is goods-to-person is also the auto store and the Ocado and those types of systems, because the totes of inventory are brought out to a pick port where a human or a robot will do the pick of the items. You can do a human or robotic pick at either one of those locations. And then another thing that we'll talk about here is these here on the bottom. So there's robotic pick systems that go to the actual storage location on a shelf, for example, and they work in two different ways. One would be like Locust or Six River, where the machine goes to where the inventory is and will communicate with the worker, and the worker would come over and they'll pick the items into a tote on that robot, and then that robot will move to another place in the storage area. The other are robots that actually go and actually pick the items automatically. And think about IM Robotics and VIA, companies like that can actually pick it. Now there's some limitations on that, of course. IM Robotics, the inventory's got to be precisely placed on the shelf. It can't just reach over there with anything anywhere it's at. So think about when you go to your local super center, when the stocker puts everything on the shelf all nice and neat, that's good for those types of systems. But once three of us grab something, look at it, and put it back on the shelf, that doesn't work anymore. We talked a little bit about pick and place robots before. Robotic sorters, an example of that is on the middle of the page here. Imagine if you could take either via a human or a robot and put an item onto a sorter that is robotic in nature and not a fixed loop sorter like a tilt tray Bombay cross belt, and then have that robot go to the location where that order or that item is needed and diverted into that container. And that's something that's really starting to take off. There are only a handful of companies that do such a thing, and Tompkins Robotics is one. But really, I've almost forgot one. The remove, replace, and transport order containers. Traditional sortation and put walls and order consolidation systems don't have a machine typically that goes and gets the completed order and takes it to packaging or delivers it to a downstream operation. There are collaborations and designs in place now. There's not a perfected one on the market right this minute. But imagine a sortation system that has a robot that goes and gets that completed order and carries it downstream and puts an empty back in place so the machine keeps running. And so that's what we mean by to remove and replace transport containers. Where a lot of companies are really getting a lot of benefit is by combining some of these technologies. For example, you could have a goods-to-person robot that brings the shelving unit out, and let's say you had 16 positions where you would deliver that, where a human would put it into put walls of 25 slots each. And you had to deliver that shelving unit to pick station 1, 6, 11, and 14. If you put a robotic sortation system on the other side instead of a put wall, you could deliver that shelving system to one location. The operator could take everything off of it for all, let's just say 500 orders, and put them onto robots, and the robots do the sortation and order consolidation. That also could be done by a robot making the move between the goods-to-person robot and the sortation robot. So a lot of companies, particularly larger companies, are experimenting and deploying and installing and rolling out en masse combinations of technologies. There's actually an installation that we've been working with a customer that has an ASR system, feeding a conveyor system, feeding pick-and-place robots, feeding a robotic sortation system, and all of those systems are sequential in the process flow with no humans except for exceptions doing the task. So when you start thinking about order consolidation and order fulfillment, I did it again. Sorry. There's a lot that you can do as far as automating. Parts are all of that. You're not going to do engine blocks the same way you would do this cell phone, but there is a wide range of the items, especially when you think about e-commerce, all the stuff that you get going to your home, apparel, footwear, general merchandise. We've all been on Amazon's website. Look at all the stuff that's there. And a lot of that product, a high percentage of it, could be automated. Packaging, here we're talking about primarily auto bag, auto box, and I won't spend a whole lot of time on this, but the whole point here is to try to minimize one of the most labor-intensive functions in the facility. The two biggest labor functions in a distribution and fulfillment center is the order fulfillment and the packing. And so if you can take especially e-commerce orders and you can auto bag or auto box those, it's out there. It won't come inside here with us, but there's a bit of drone out there apparently all day. This technology is fairly mature for certain product ranges and certain order profiles. It is in wide use, especially think about people who have low value goods and high quantities per order and a lot of soft goods, for example. And ideally, I'm thinking right now about children's apparel. Almost all of their merchandise and e-commerce orders are bagged for children's apparel. Because of dim weight, they're trying to maximize the density for that. And it lends itself very well to that. As a matter of fact, I know of one children's apparel manufacturer, distributor, order fulfillment operation. 98% of all orders are bagged. And they use auto baggers for all of that. And so there's a high level of use of automated packaging for certain industries, certain product types. Other things are a little more difficult. So as we talk about a summary of, is lights out realistic? I mentioned earlier that facility in China for JD.com is not really lights out. There's a lot more than 4 people working in the building. Right now in the United States, and we're as advanced as anywhere else in what we can and do in distribution, they're not lights out facilities. The only one I know of are places where it's like AGVs and ASRs, but it's only a portion of the building. They can't do order fulfillment like that, but they do storage and retrieval. As I said before, storage and retrieval is the one area where you really can turn the lights out today. Everywhere else, there are exceptions. There are certain things that have to be done by humans. There's just no way to do it all 100%. As a matter of fact, when we talk with customers about doing robotic blending of various technologies, we set a goal in their mind of 80% of all human touches are automated, but there's no way to get to 100%. And if you think about things like gift wrap and exceptions on handling and different shapes and sizes, you can see where there's just no way to fully automate all of that today. Maybe somewhere down the road, but not now. There's also maintenance, machine operators, there's management, there's people working screens, there's people driving the workflow, making decisions. So in addition to the people who have to be there to do the things that machines can't do, there has to be all the other people that make the whole thing work. And so those people have to be near the workflow of where they're at so they can see and observe what's going on, to correct things that's needed, to repair things that's needed. So all of these things on the page here make it impractical and unrealistic to have a fulfillment center that you're all standing in the parking lot and it runs for 8 hours by itself. It just doesn't happen. We still require a skilled workforce. While robotics and automation helps and eliminates a lot of the tasks that can be in the facility. it doesn't take care of everything. And so it does help in a lot of ways. So if you deploy robots, robots work 3 shifts, 7 days a week. They don't take breaks. They don't call in sick. They work all the time. So for those repetitious, those difficult to do, those taxing human type of tasks, why not have the machine do that? Especially if you can apply it in a manner so that you can get enhanced performance and productivity and capacity out of existing assets, being buildings and locations and management. And so it leverages your existing staff that you have. A lot of times people say, aren't robots going to take away my job and put me out on the street? The answer is no. When unemployment is 3% and you're growing 5% a year in your business, you just redeploy those people to do other tasks in the building and retrain them to do things like maintain the equipment. And so while there may be some degradation in jobs in certain installations or certain locations, many times it's leveraging the same workforce over longer periods of time, more shifts, more days per week to accomplish more volume with the same physical assets. So jumping to the bottom of the page, oh, I got a little loud there. Is that me or is that, okay. So what we think is realistic is the 80% of the touches that I was talking about before, and maybe about 60 to 85% of all the workflow processes could be automated. There's just no way to really do the entire thing in the facility and make it all lights out. So with all that said, the key takeaways we wanted to make sure people got here is there's a lot you can do. We think that where we've come from 5 or 10 years ago is astronomical and amazing. What you'll see out here 2 years from now, next time it comes to Atlanta, some of it will blow your mind, and some of the stuff that you see here now may be gone away, may have been replaced by new technology that's even better than what you're seeing out here today. But there is a lot of opportunity. Robotics is the future. It's not going away. It's going to replace traditional systems. There's no doubt about it in my mind. As a matter of fact, at Tompkins Robotics with our robotic sortation system, no less than 5 different large-scale integrators have talked to us about partnerships wanting to be a reseller of our equipment while we've been at this show, and we already have partnerships with several that are here already. And so they recognize where it's all going. It can help with all the constraints that we talked about, and it is really effective in many situations. We can't do lights out right now. Will we be able to down the road? Probably so. I would not be willing to bet money on when that day is, because there's always going to be things like gift wrapped and things of that nature. I just don't see that being automated anytime soon. So there's certain things that people are going to have to do. And if you think about it, machines only know what they're told. Someone's got to tell them what to do anyway. Takeaway, if you're evaluating robotics for your operation, look at what your constraints are, try to figure out where you have needs, develop a plan. What you would do is you would need to write requirements about what you need to automate and how robotics would fit there. Understand, do some research about the robotic options that you have for yourself to meet those requirements. Learn how to, or figure out how you can integrate different technologies. I don't think anyone out here really has a fantastic end-to-end solution all in one house to do everything and automate it. Sometimes, and many times, you have to do best of breed, partner with 2 or 3 different firms that specialize in different areas and blend them together and integrate them to get the best thing for you. And this next point is one to keep in mind as well. As much as we progress with robotics, don't buy robotics just for the sake of the sexiness of it or the hype of it or whatever. Make sure the application's good economically and operationally for your business. Sometimes people just buy something because it's a cool new toy. That's not the way to use robotics. And so, with all that said, I'll open it up to questions. Either I did a fantastic job or you guys are sleepy with the mid-afternoon doldrums. I'm sorry.
On warehouse safety with the use of robotics?
Okay, the question was, are there any concerns about safety in the warehouse with the use of robotics? Not really, and here's the reason why. The collaborative machines are designed such that they will stop and not injure a human being. And the machines that are dangerous to a human to be beside and work, they're fenced off. So for example, an auto store or an Ocado, the robots are on top of the storage cube. They're not even anywhere near the humans are. In the case of pick and place robots that are not collaborative, they have fencing around them to keep you from being able to get hurt. And so they have designed all these, and OSHA and other entities check these out and certify whether or not the machine is safe for the workplace environment and what rules it has to go for. And on top of that, for the companies that have European operations, CE certification is even worse than that. So if you get CE certification, you're pretty sure you're not going to, anyone's going to get hurt. Anyone else? Thank you very, very much. Enjoy the rest of the show.